Hey guys, in this lesson we're going to go ahead and we're going to verify solutions to differential equations. And I created these questions and I try to mimic what you might see on the AP exam, so hopefully it'll help you. So let's go ahead and do the first one. It says, for what value of k does y equals k cosine of 3x plus 4 sine of 5x become a solution to the differential equation given by this one? So at first it becomes a little confusing, right? Because what does this mean? But essentially what this is telling you is the second derivative here and then the y here, you're going to have to plug it in and you're going to have to equal it to this and you're going to have to solve for x. So you're going to have to find the second derivative of this guy. Okay, plug it in here. And this is y, so you're going to plug it in here, do your algebra, and solve it. So let's go ahead and do, first we're going to find y prime. Okay, so y prime, okay, is, we got to take the derivative of this guy. Remember, the k is a constant, so we're going to cover it up. What's the derivative of cosine? Well, derivative of cosine is negative sine, okay, of 3x. But because we have something on the inside, due to the chain rule, the derivative of 3x is 3 times the k, it would be negative 3k. Okay, plus the derivative of this guy. Cover up the 4. The derivative of sine is cosine. Okay, cosine of 5x times the derivative of the inside, which is 5. And so 5 times the 4 would give you 20. So that's the first derivative, okay? We need the second derivative, so let's go ahead and do it one more time. So, again, I'm going to cover up the 3k. The derivative of sine is cosine, and cosine of 3x. And because we have something on the inside, times 3, so 3 times the negative 3k would be negative 9k. Plus, actually, we're going to use a negative actually. Cover up the 20. The derivative of cosine is negative sine, so negative sine of 5x. Because we have something on the inside, the derivative of 5x is 5 times the 20 is negative 100. Cool, so now we have our second derivative. And hopefully you were able to follow that. Now this guy is going to get plugged in here, times plus 25 times the y. You're going to plug in this value. So let's go ahead and do that. Our second derivative is negative 9k, k times cosine of 3x minus 100 sine of 5x. Okay, so that's this guy right here, plus, and I should have given myself some more room. I'm going to continue down here, okay, plus 25 times, now I'm going to put a y, okay, I'm going to put all of this here. So we're going to have k cosine of 3x, okay, plus 4 sine of 5x. All right, and that's going to equal 16 cosine of 3x, equals 16 cosine of 3x. Cool. All right. So we're going to do our algebra now. So y double prime is right here, plus 25 times all of this, y, equal to this. So let's see here. Nothing I can do here. I'm going to distribute the 25. So let me rewrite the negative 9k. Negative 9k cosine of 3x minus the 100 sine of 5x. Okay. Plus distribute that 25. You're going to get 25k times cosine of 3x. Notice that I'm only multiplying the constant in the front, not the 3x. And then 25 times 100, that's going to give me 100. I'm sorry, 25 times 4 is 100. Sine of 5x, that's going to equal 16 cosine of 3x. Cool. What do you do now? Do our algebra. Negative 100, positive 100, sine of 5x. You see that? That's going to simplify out. That's going to give you a 0 there. Now we have these two. Negative 9 plus 25 is going to give you, what is that, 16? So 16k cosine of 3x Yeah, 25 minus 9, there you go, equals 16 cosine of 3x. Cool. And then now we're just going to solve it. Just like if we were doing algebra, you know, divide by 16 cosine of 3x, divide by 16 cosine of 3x, and actually k ends up equaling to 1. All that for a 1. Yep, that's it. But you notice what I had to do? First, take the derivative, take the second derivative, and then we're plugging them in here using our algebra skills and simplifying it out. Let's look at another example, okay? Here we have three options here, okay? So we're gonna do the same thing, okay? So first and second derivative minus the original, the y, is it gonna equal to 0? So I'm gonna start with the first one. So let's see here. The first derivative of this guy, cover up the 3. The derivative of cosine is negative sine of 2x times the 2, the derivative of the 2, that would give me a 6. Okay, and then our second derivative of this guy. All right, we're going to do, what's the derivative of sine? Is cosine of 2x times the derivative of 2x, which is 2. That gives me a negative 12. Okay, so now if I plug this guy into here, this guy into here, and this guy into here, and then this guy into here, is that going to give me a 0? So let's go ahead and see. So y double prime is negative 12 times cosine 2x plus 3 times y prime is negative 6 sine of 2x. Okay, and then minus 4 times y. Y is 3 cosine of 2x. And is that going to equal 0? Well, let's see here. This will give me, this is just negative 12 cosine of 2x. And this is going to give me negative 18 sine of 2x. And this is going to give me negative 12 cosine of 2x. Is that going to equal to 0? Well, if you know, this guy's going to cancel out, but this guy is not going to equal to 0. Okay, so the answer is no. It's not a solution. All right, let's do this next one. Number 2. So first I need the second derivative. So first derivative of this guy, cover up the 4. The derivative of e to the x is e to the x, and then just times the 4. All right. Next, second derivative. Cover up the 4 again. The derivative of e to the x is e to the x, and then just times the 4. So this is nice. It's doesn't change at all, which is great. So now we're going to do the same thing. So the second derivative, we're going to go ahead and plug it in there. 4e to the x plus 3 times the first derivative is 4e to the x minus 4 times the y. The y is the same thing, 4e to the x. Is that going to equal to 0? All right, so 4e to the x plus another 12e to the x minus 16e to the x. Is that equal to 0? And you know what? 4 plus 12 is 16 minus 16. Yes, it is. It works. So we know at least this one is an answer. Okay. Well, what about the last one? Okay. This one I wanted to give it to you because it has that constant. It's kind of confusing sometimes, but it's similar to number 2. Okay. So let's go ahead and do that one. So I need the first derivative and the second derivative of that one as well. Okay. So first derivative, cover up the constant c. The derivative of e to the 5x is the same thing, e to the 5x. But because we have the 5x on the top, the chain rule, the derivative of 5x is 5 times the constant c. You're going to get 5c. Okay, that's the first derivative. Second derivative, same thing, cover up the 5c. E to the 5x is going to give you, e to the 5x. Okay, e to the 5x. And then the derivative of 5x is 5 times 5c is going to give you 25c. Okay, and so this guy is 25c e to the 5x. All right, so I took the derivative, the first derivative, second derivative. Now I'm going to plug it in here. So second derivative is 25c e to the 5x plus 3 times the first derivative is 5c e to the 5x minus 4 times y. It is c times e to the 5x. We want to see if that's going to equal to 0. And this is going to give me 15. This is going to give me 4. So 25 plus 15 is 40 times c e to the 5x minus 4c e to the 5x. And is that going to give you 0? No, it's not. 40 minus 4 is just something else. The answer is no. So the only one that satisfies the solution, it will be number 2. So hopefully it making sense, guys, where you have to take the derivative, plug them in here, and then just do your math. All right, let's do a couple more problems. Let's do this one here. For what value of k is this equation a solution to the differential equation? We're going to do the same thing. We're going to this is our y already. We got to find y double prime. Okay, so let's go ahead and see if we can do that real quick. So y is there. Y prime is e to the 3x is going to give you e to the 3x, but because of that 3x on the top, we'll give you 3 plus, cover up the k, e to the negative 4x is the same thing, e to the negative 4x times the negative 4 on the top, so it's going to actually be a negative 4k. Okay, that's the first derivative. The second derivative, okay, notice this is a minus, this is a minus. Second derivative, same thing. We're going to do e to the 3x becomes e to the 3x times the 3 on the top, which would give us a 9. And then, let's see here. Cover up the negative 4k. E to the negative 4k is the same thing. E to the negative 4x, I'm sorry. The derivative of negative 4x is negative 4 times the negative 4k would give you a positive 16k. And then you have your second derivative. So now I'm going to plug it into here and see if it gives me that. And I'm trying to find that k value. So we're going to have, let's see, 3. The y is this guy, so e to the 3x plus k e to the negative 4x minus, now I got to put my double prime. So that'll be 9 e to the 3x plus 16k e to the negative 4x equals negative 6 e to the 3x plus 65 e to the negative 4x. All right, so I got to solve that now. If I distribute here the 3, I'm going to end up with 3e to the 3x plus 3k e to the negative 4x. Distribute that negative is going to negative 9 e to the 3x minus 16k e to the negative 4x. Is that that's going to equal negative 6 e to the 3x plus 65 e to the negative 4x. Cool. All right. Now let's see. We're going to put these two together. That's going to give me a negative 6. Negative 6 e to the 3x. We're going to put these two together. That's going to give me 3 take away 16. It's negative 13k e to the negative 4x equals to negative 6 e to the 3x plus 65 e to the negative 4x. Cool. What's going to happen is you're going to add 6 on both sides, right? And that's going to simplify this out. And so now you're going to have negative 13k e to the negative 4x is equal to 65 e to the negative 4x. You're going to divide by negative 13 e to the negative 4x. And you guys will probably already see it. All right. These guys become a 1. So k, 65 divided by negative 13 is negative 5. Boom. Nice. Not too bad. Just seems like it's a little bit tedious. Now these I created myself. I think these are a little bit longer than you would probably see on the AP exam, but it is what it is. Let's do one more. All right. Same thing. For what values of k will this function be a solution to the differential equation given by this guy? Same thing. You can pause the video and see if you can do it on your own, or you can go follow along. So I need the second derivative. All right, so the first derivative, cover up the k. e to the negative x is the same thing, e to the negative x, but because with a negative, you're going to multiply by negative, and then you still have that k. Derivative of cosine is negative sine of 2x times the 2 on the inside. Okay, chain rule, that would give you 2 times 3. This guy times the 3 on the outside, that gives you a 6. So that's the first derivative. Now the second derivative, same thing, cover up the negative k, e to the negative x is e to the negative x, times the derivative of negative x is negative 1, times the negative k gives you a positive k. The derivative of sine is cosine of 2x, times the derivative of 2x, that's 2. 2 times negative 6, that gives you negative 12. All right, I got my second derivative. I'm going to plug it in there. Let's see here. Hopefully I give myself enough room. So I have k e to the negative x minus 12 times cosine of 2x plus I have 3 times y. This is my y value. K e to the negative x plus 3 times cosine of 2x equals all of this guy. That's going to be 8 e to the negative x minus 3 cosine of 2x. All right, let's do some algebra. All right, this guy can't do anything. I'm going to distribute the 3 over here. So let's rewrite that. K e to the negative x minus 12 cosine of 2x plus 3k e to the negative x plus 9 times cosine of the 2x. And actually, I don't need this extra parentheses here because I distribute it. Equals 8 e to the negative x minus 3 times cosine of 2x. All right, let's see, what can we put together? These two together, so the k and then 3k is going to give me 4k e to the negative x. And then these two, negative 12 plus 9, is going to give me negative 7 cosine of 2x. Cool. Is going to equal 8 e to the negative x minus 3 cosine of 2x. All right. And let's see here. We're going to go ahead and combine these. So let's go ahead and I'm going to bring this guy to the left so it becomes a minus. And I think I might have, let's see here, minus 8 e to the negative x. And then switch that one over, cosine of 2x minus 3 cosine of 2x. And 4 minus 8 gives you negative 4. And e to the negative x equals 7 minus 3. That would give you 4 times cosine of 2x. And I actually forgot my k right here. Let me just put it here. Right there. There's my k. Now, I was hoping that something would cancel out, and it did. No, it's okay. Let's go ahead and... So we're going to divide by negative 4 e to the negative x divided by negative 4 e to the negative x. So what does my k value equal? The k value is going to equal to cosine of 2x over, well, this becomes a negative 1. Okay, I'll just put the negative on the top, and then e to the negative x. You can write it like that, or what you might see negative e to the positive x times cosine of 2x. Remember, when you bring it to the top, the negative exponent becomes positive. And, well, this one we didn't get a whole number, but we got an abstract value, and that's okay. But hopefully that makes sense. In order to, you take the derivatives, you plug them in, you do your algebra, and just be careful with how you solve it, guys. But let me know if this helps. Hopefully it does, and I'll see you guys next time.